So last time we were able to set up a pretty successful class for complex variables. We've got all the sort of built-in functions you need, like a modulus, a phase, a complex conjugate, and we even made a string function so that we can print out our complex values in a readable format. But of course, we need to be able to do some arithmetic with these things. We need to be able to add them, subtract them, multiply them, etc. So what I'm going to do today is get those functions set up. So what we're working with now are considering two complex variables. So we've got a plus ib for z, we've got c plus id for another complex variable q. And so if I wanted to add these, z plus q, you just basically follow the standard rules for addition from algebra. You just keep an eye on this imaginary number here. So we've got an a plus ib, that's supposed to be a plus sign, plus c plus id. And basically what you do is group together everything that has an I and everything that doesn't have an I. So I've got an IB over here, and I've got an ID over here, and then I've got an A without an I here, and a C without an I here. So I can group those together and think of this as being like A plus C plus B plus D being multiplied by I. So here's everything that doesn't have an I, here's everything that does have an I. And if you look at it, what you've got is a real part here, something that's not being multiplied by I, and you have an imaginary part here, something that is being multiplied by I. So you end up with a new complex number that has a real part of A plus C and an imaginary part of B plus D. So we can implement that over here in our code pretty easily. So let's make a new function, call it add, and we're going to have to make this one self, comma, and another complex variable. Let's call that one q, just to make it easy. So what we're going to return now is a new complex variable with a real part of self.real plus q.real. And then an imaginary part of self.imaginary plus q.imaginary. And so let's clean up this over here. I don't necessarily need these anymore. There we go. And so what we're going to do is let's make a new variable. Let's call this z equal to complex variable. Let's make these numbers easy to check on. 1, 2. So this is going to be 1 plus 2i. And let's make one q of complex variable. And let's make this one 2, -3. So let's have this thing print. So the way this works is we've got a function add, where it's going to add the two together, but it's attached to one of the complex numbers. So what I have to do is take one of these, might as well just use z, and say z.add, and then give it an argument q. Notice I don't repeat self in there because it automatically associates self with the original listed number here. All right, so let's close this up. So we should get a 1 plus 2 plus an I times 2 minus 3. So I should get 3 minus I times 1. Oh, and I need to say dot string. Control 2. 3 minus I times 1. Wonderful. Okay, so that's addition. We should also have a subtraction. Define subtract self, comma, q. And all I have to do here is use the same kind of setup. So I'm just going to copy and paste and just subtract the q's because I'm subtracting q from it. So if we go back to our algebra over here, you just imagine replacing this replacing this plus sign with a negative. So that means this becomes a negative, this becomes a negative, so you have a minus c and b minus d. And that's exactly what we're coding over here. Self minus q, self minus q. There we go. So let's do the same thing now. Print, copy and paste, z.subtract. All right, so now I should have 1 minus 2 and 2 minus -3. So this is a good test of this. And I end up with a 1 minus 2 gives me a -1, and a 2 minus -3 gives me a +5. Awesome. All right, now comes the fun part, and that is multiplying these two together. So let's say you've got your first complex number z equals a plus ib, and q equals c plus id. When I multiply these together, so say I take z times q, I just take these and use the basic FOIL rule, right? A plus ib times c plus id. I've got two things added together, multiplying two things added together. So I really just follow the FOIL rule. So I take the first terms, a times c, plus the outside terms, a times id. So let's call that iad. Plus the inner terms, here I've got I times b times c, I times b times c. And then I take the last terms, plus I've got an I times a b times a d. So I've got I squared b times d. And now this is where we have to do a little bit more work. Because remember, I is the square root of -1. It's this weird number that in 6th grade they told you wasn't supposed to exist. But that means if you take I and square it, you've got -1. So you never need to have an I squared left over in a complex numbers problem. You just need to replace it with a -1. So my z times q is going to be ac, that's fine, plus iad. Oh wait, I've got another I over here, so I might as well group those together. So I've got AD plus BC. And now I've got a minus B times D. And so again, what I want to think about is this is another complex number. And so I've got a real part made out of these two. So that's sort of my combined real part. And in this thing, I've got my combined imaginary part. So when I multiply two complex numbers together, I get back out another complex number with a combined real part of a times c minus b times d, and then a combined imaginary part of a times d plus b times c. So let's encode that over here. So we're going to have define multiply self comma q, set it up the same way. We're going to return another complex value, and let's see here. We need to have the two real parts multiplied together, so that's what AC is. I've got the two real parts multiplied together. So I've got self.real times q.real. And then I need to subtract the two imaginary parts multiplied together, minus b times d. So I need to have minus self.imaginary times q.imaginary. And that long thing is just the real part. Now I have to put in the imaginary part. So the imaginary part, we call this the cross term because you've got the real part of one times the imaginary part of the other, plus the imaginary part of the one times the real part of the other. So this is going to be self.real times q.imaginary plus self.imaginary times q.real. Close parentheses. So the first term is weird because it's one thing minus another thing. The second term is weird because you're mixing the real and imaginary parts. Multiplying complex numbers is a weird thing that happens sometimes. Actually happens a lot. So let's try print z.multiply q.string, not forgetting that this time. And let's give that a try. Control 2. Okay, so we've got 8 plus I times 1. Let's do a little bit of a check there. So let's see, our first two multiplied together gives me a 2, and then I need to subtract from that the imaginary part. So I've got 2 minus a -6 gives me an 8. Got an 8 right here, perfect. And then I need to take the sum of the cross terms. So 1 times minus 3 plus 2 times 2. Well, 2 times 2, I always start with a positive number because my brain just works better that way. 2 times 2 gives me a 4, minus 3 times 1 gives me a total of positive 1, and that's what I end up with right here. There's one other trick I'll leave you with for this video. One of the cool things about complex numbers is that there's always more than one way to get the same thing. So when we take the modulus of a number, modulus, so if we take the modulus of z, the standard way to do it is to take its take this square root function here of real squared plus imaginary squared all under a square root. And that works fine. But another way that you can get the modulus is by taking a number and multiplying it by its complex conjugate. So I can take multiply by z dot conjugate dot string. And what that does is it gives you the modulus squared. So let's, for comparison purposes, take the modulus squared here. Control 2. So here we go. The modulus squared is 5. And then if you take the number and multiply it by its complex conjugate, you get 5 plus I 0. So this is really just a real number. Anything with a 0 imaginary part is just a real number. So we've got 5 and 5 there. So that shows you that there's another way you can get the modulus, which is pretty handy. So there are 2 other mathematical operations we haven't done yet, and I think we'll save those for another video. And that's multiplying a complex number by a real number, which is pretty straightforward. That should be pretty easy to code. And then there's dividing complex numbers, which I'll be honest, I haven't had to do that since high school, but some of you might need to do that, so we'll build in that function next time. So thank you so much for watching. I will see you next time. Bye-bye.